All right, so let's make some mathematics work for this. So the first thing I want to do is I'm going to make a space. All right, there, I've made a space. And this space represents all of my sample space. So I'll say sample space. We can think of it as being filled with tiny little dots, right? Like a picture, when you look up close to it, there's little pixels on it. And each dot is a possible outcome. And my sample space is covered with it. In fact, we're going to use the language of area sometimes to do this. Like I can paint it or I can cover it with outcomes. And so in my sample space, I'm going to change my color here. In my sample space, I have a collection of outcomes that are my E. And they cover an area, some percentage. So all of my sample space is 100% of all possible outcomes, right? And we'll use the number 1. And then inside of this circle are all of my events. I surround my circle with or I surround all the possible events and I put them in a circle, and it covers an area. Now it's not 100% of the sample space, but it covers part of it, which means that the things that aren't my event, I'll mark with this little bar, and we're going to call that the complement. And so if E is an event, the complement of the event, E prime, is all outcomes in the sample space not in E. Okay? And so we call that the complement. Okay, what can we get from this? Well, it begins our mathematics for us. Because if I say the probability of picking something in E plus the probability of picking something in its complement, well, that's 100%. Right? If all my possible outcomes are here, what is my chance of picking either in E or out of E? Right? Picking E or its complement. Guaranteed. If I'm drawing from my sample space, it has to be one or the other. And this starts my algebra. From here, I can do some manipulations, and the rest of this chapter is doing manipulations with this idea and figuring out how much area these things cover, one event or multiple events will cover. And so, well, let's do a little manipulation here. Let's say, hey, what is the probability of just my event? Well, if I subtract the complement from both sides, I get 101 minus the complement tells me the probability of my event. 100% minus something else gives me my event. And the probability of my complement is the same thing. 1 minus P, the probability of my event. And this is all dependent on one thing about probabilities that we should see here, and I said, but I want to mathematically put it together here. This isn't covering all of my sample space. It could, but it couldn't cover more. Right? I can't have an event that goes outside of my sample space because there's no outcomes out there. And so that limits the values that any probabilities can be. And so what nicely happens for us is the probability of an event is less than or equal to 1. At most, it can be 100% guaranteed to happen. And it's greater than less than 0. At the worst, it can't happen at all. But there's no meaning to the idea of, I have a 150% chance of happening. What does that mean? I have a negative 5% chance of happening. Well, what does that mean? And so let's use this here to help us out. Let's see if I still have it up here. Did I rearrange this? I want to go back here. And we're going to look at this frequency table. And I'm going to say, you know what? I only want to know the people who are not of retirement age. So notice I use the word not of retirement age. So what is the probability? Probability in my social networking survey of picking someone not of retirement age. Well, the not's my key here. And so what I want to think of is my event I'll make picking someone of retirement age. And for lack of better notation, we'll say that's 65 plus, because that's what it is in the US. And so E prime, right? E, the complement of that, is someone not 65 plus. So we want to find the probability of E prime, or the complement of E. And so what I want to do is I want to say, you know what? I want to subtract the probability of that event. I'm going to come back up here and I'm going to look at this here and go, all right, so there are 58 people of retirement age in the 975. So P of E is 58 out of 975. Now here's a hint. Don't divide this in your calculator yet. Just leave it as a fraction. All right? Well, we're going to let the fraction do the work. And so what I want to do here is I'm going to say the probability of picking someone that isn't retirement age is 1 minus 58 over 975. But notice, hey, you know what? I can write the number 1 many different ways. I can write it as 3 over 3, 5 over 5, or 975 over 975. And so I'll go 975 over 975 minus 58 over 975. And so I'll run to my calculator. Let's run to my calculator. Run. Hey, there you are. And so, well, the numerator of my fraction is 975 minus 58, or 917. So let's come back here. And that gives me 917 over 975. All right, because I have the same denominator, all I have to worry about is the numerators. And now, again, running back to my calculator, 917 divided by the 975 says 0.9405, or about a 94% chance. And so my probability about a 94% chance of picking someone who didn't retire. Now, please, I have seen many people go to figure out complements, and they go through and they add up everything that isn't the 65. What we're going to find is using this idea that in its entirety, everything has to equal 100%, or 1 in the ratios that we're doing, leads to these nice rules with the complements and makes our math a little easier. Plus, once we start dealing with how different events combine together, this is going to help us work our way through. All right, that's the end of section 1. I will start some videos for section 2. If you need anything, please shout. And now I have to hit stop.